Find the area. I'm not even going to tell you what shape it is. Find the area. Oh goodness, if you can't tell me what shape that is, we are in a lot of trouble, everybody. I've had kids tell me that's a rectangle before. I've had a couple kids say it's a triangle, you know, that's a rhombus. No, trapezoid. This is a trapezoid. It's an upside down trapezoid is what it is, but nonetheless, trapezoid. We're going to say that this is 16 centimeters. We're going to say this one down here is 6 centimeters. And I'll give you the height. It has to be perpendicular. It should be perpendicular to both. You know, if these two are parallel, it has to be perpendicular to both. And this is going to be 5 centimeters. Let's do an easy one. And then the next one, I'll kick it up a notch. Kick it up a notch. Alright, area equals, do I need to look at the last page? No, I don't need to look in the last page. Area equals 1/2 the height times base 1 plus base 2. Be careful with this one. Actually, no, I do need to flip to the last page because I need to show you something. Stop what you're doing, folks. I need to show this to you. Please do not mix up these formulas. Notice how it's multiplication here, it's multiplication here, and it's addition here. Please do not mess this up. You're adding the bases together. However, over here, you're multiplying the diagonals. Okay, got it. Everybody's got it. Sweet. Plug it in, see what we get. If you need to take a look at what I'm doing, that's fine. Take a look at it. 16 plus 6. Okay, you can add these together on the inside. What's that going to be? 1/2 of 5. 16 plus 6 is 22. Now you can multiply the numbers together. You punch all this in the calculator, your call. I'm just going to multiply the two whole numbers together. Because 5 times 22 is, I think, 110. And then take half of 110, and you've got yourself 55. Go ahead and label correctly, centimeters squared. Easy. Nothing to it. Nothing to it. Plug the numbers in the correct spots. Go from there. All right. What if I don't give you one of these numbers? Let's say I don't give you the height. That's what I'm going to do on the next problem. To an extent. You'll see. You'll see. Once again, find the area. Let's give you another trapezoid, but let's give you a right trapezoid, everybody. And make this one large if you could. Okay, right angle right there. It's assumed that there's a right angle right there if this is in fact a trapezoid. So just one, that's all you need. Okay, that's 4 feet. That's 5 feet. And that's 9 feet. And that's all I'm going to give you, folks. That is all I'm going to give you. Perfect. We're missing a little information here. For one, we need the top base. We're not given that. Do not make an assumption. Don't just guess numbers. Don't just say, well, that's 5, that's 9, that's got to be, kind of looks like 7. Don't do that. You need to know what you're doing. But we need to find this missing piece of information. I suppose the first thing we could do is set up the equation. I mean, there's nothing terrible about doing that. We can at least get going in the right direction. It's a trapezoid. It's a right trapezoid. So it's going to be the same equation that we had above. Base 1 plus base 2. And you can actually go ahead and start plugging some numbers in. You know, we have the height. It's 4. So we got the height. And we have one of the bases. I mean, these are the two bases. We got the top base and the bottom base. Bases are always parallel to each other, so those are the two bases. We've got one. We don't have the other. So we got 9 plus, this is what we need to find. Because we find the other base, we plug it in here, we got the area, we're done with this problem. We need to find the other base. I wish we were doing this in the classroom. I think I said that a couple times on my last video as well, but I truly mean that, everybody. It's so much easier to learn in a classroom when I can see your faces and see how you're learning and seeing if this stuff's making sense. I mean, I can't see you guys, anybody. So it just stinks. It stinks, but we're making the best of what we got. All right, base 2. How do we find this? Do we guess? No. Here's something I'd like you to do. You know that the height is 4. I'd like you to come over here. You know the distance from here to here is also 4. Go ahead and draw a vertical distance right there, everybody. You know it has to be a right angle, and you know that height has to be the same as the height over here. It's 4 feet. So if this is 4 and this is 5, I want you to look at this right triangle for me. I would like to find this last leg of the right triangle. This distance from here to here. Let's call it x. Let's go ahead and use the Pythagorean theorem. Find this distance. See what happens. Let's see. A squared plus b squared equals c squared. X squared plus 4 squared equals 5 squared. Small numbers. I like that. X squared plus 16 equals 25. Subtract 25 on both sides. Or subtract, wow, back up, Kosal. Subtract 16 on both sides. And then square root, you've got x equals 3. Folks, this is a 3, 4, 5 right triangle. It's a 3, 4, 5. It's a very common, it's the most common right triangle out there. It's a 3, 4, 5 right triangle. So if this distance is 3 and the total distance is 9, let's see, how's that going to help you? How's that going to help you? Well, if the total distance is 9 and that's 3, you know that this has to be 6. 3 from 9 is 6. So that has to be 6, which, look at this figure now. I mean, we kind of broke this trapezoid up into a rectangle and a right triangle. Rectangles have opposite sides that are the same, so if this is 6, that's also 6. You've got your second base. So we've got 1/2 the height, 4, parentheses 9, the bottom base, plus 6, the top base. I'll meet you at the answer, everybody. And you can go kind of fast here. You can say that 9 plus 6 is 15. And you can actually do the multiplication with the 1/2 immediately. I like this because if it's right next to an even number, I can just cut that in half. 2. You know, 1/2 of 4 is 2, and 9 plus 6 is 15. 2 times 15 is 30. 30 feet squared. Not bad. Not bad. All right. Example 3. Last example, folks. Last example. I'd like you know, we haven't done a rhombus or a kite yet. Not that they're hard. I'd like you to find the area of both. I want to use the rest of this piece of paper. I do not want to use another sheet of paper. Let's do an A, and let's do a B. Let's start off with a kite. Alright, these two are the same, these two are the same. Doesn't really look like a kite, but we're going to say it is. It's a kite. It's a kite. Okay, here's one diagonal. I call that the short diagonal. And then here's the long diagonal. And let's see, what are we going to give you? I'm going to tell you the distance from here. Red pen's dying. Distance from top to bottom, so we're representing this diagonal right here, folks. That is 12 feet. And this distance from here to here, representing the other diagonal, is 7 feet. Let's go ahead and find the area. Simple one. Area equals 1/2 diagonal 1. Is it multiplying or is it adding? It's multiplying. 1/2 d1 times d2. Plug it in. Let's see what you get. 1/2 d1. Folks, it doesn't matter. It's multiplication. It doesn't matter if the 7 comes first or if the 12 comes first. It does not matter. 7 times 12, d2. Let's see. 7 times 12 is 84. Yep. 84. And then 84, half of 84 is 42. 42 feet squared. If I were to color this entire kite in, it would be about 42 feet squared of paint, of crayon, of marker, whatever you're coloring it in with. Let's do one more, folks. I'm going to try to do a curveball here. Let's do a diamond. Rhombus. Alright, another property of rhombuses, or rhombi, I should grammatically say that correctly, is that these two pieces are the same, and these two pieces are the same. And every single side is the same, so that is the same as that, is the same as that, is the same as that. You got a lot going on with a rhombus, folks. Okay, I'm going to tell you that this piece is 7 inches. Now, I'm talking, I should probably highlight this, or something so you can see it. It's difficult to see this in the book, but you'll know. They're talking about the distance from that vertex to the intersection of the two diagonals. And this distance from the intersection to the very bottom is 9 inches. That's all you need. Let's find the area, folks. Area equals same equation as a kite, 1/2 d1 times d2. Ah, darn, we don't have the diagonals. Oh shoot, guess we can't do this problem. Yeah, you do. Yeah, 7 inches, 7 inches. These two have to be the same, so the entire diagonal has to be 14. And then diagonal 2 has to be 18, because if that's 9, so there's your 18. You know what? I'm going to do the 1/2 and the 14. 1/2, 14, 7. And then just do 7 times 18. That is, I think, 126. 126 inches squared. Folks, we are done. Not bad for today. Pretty fast notes. Your homework is on page, once again, midnight. I need this by midnight. Some of you do a great job of getting this done in the morning or even the afternoon. Some of you are still waiting until 11 o'clock at night to start the video. Bad idea. 1 through 3, 5 through 13, 46, 47, and 54. Alright, folks, make sure I get this by midnight. And, you know, everybody, have yourselves a great Monday. And we'll see you on Wednesday. See ya.